And the other device, which I'll draw over here schematically, no, maybe I'll draw it on this blackboard here. So method 2, if you like, this was method 1, and we should call it the hard way. Method 2, which is better in this case, is to use horizontal slices. Let me draw the picture. At least schematically, here's our picture that we had before. And now, instead of slicing it vertically, I'm going to slice it horizontally, like this. Now, the dimensions have different names, but the principle is similar. The width we now call dy, because it's the change in y. And this distance here, from the left end to the right end, we have to figure out what the formulas for those things are. So on the left, maybe I'll draw them color-coded again. So here's a left, and whoops, I don't know, orange is right, I guess. So here we go. So we have the left, which is this green, is x equals y squared. And the right, which is orange, is y equals x minus 2. And now, in order to use this, it's going to turn out that we want to write x's. We want to reverse roles. So we want to write this as x as a function of y. So we'll use it in this form. And now I want to set up the integral for you. This time, the area is equal to an integral in the dy variable. And its starting place is down here. And its ending place is up there. This is the lowest value of y, and this is the top value of y. We've already computed those things. The lowest level of y is -1. So this is y equals -1, and this top value is y equals 2. So this goes from -1 to 2. And now the difference is this distance here, the distance between the rightmost point and the leftmost point. Those are the two dimensions. So again, it's a rectangle, but its horizontal is long and its vertical is very short. And what are they? It's the difference between the right and the left. The right hand is y plus 2, and the right hand is y squared. All right? So this is the formula. What was the question?
Why is it right minus left?
Why is it right minus left? That's a very important. Why is it right minus left? And that's actually the point that I was about to make, which is this, that y plus 2, which is the right, is bigger than y squared, which is the left. So that means that y plus 2 minus y squared is positive. If you do it backwards, you'll always get a negative number, and you'll always get the wrong answer. Right? So this is the right-hand end minus the left-hand end gives you a positive number. And it's not obvious, actually, where you are. There's another double check, by the way. When you look at this quantity, you see that the ends pinch. And that's exactly the crossover points. That is, when y is equal to -1, y plus 2 minus y squared is equal to 0. And when y is equal to 2, y plus 2 minus y squared is equal to 0. And that's not an accident. That's exactly the geometry of the shape that we picked out there. So this is the technique. Now, this is a much more routine integral. I'm not going to carry it out. I'll just do one last step, which is that this is y squared over 2 plus 2y minus y cubed over 3, evaluated at minus 1 and 2, which, if you work it out, is 9/2. So we're done for today, and tomorrow we'll do more volumes, more things, including 3 dimensions.